Hi, everybody. Today, you can see our title up on the top of the screen. We're going to go through and we're going to address our last fraction operations. That is, last time we dealt with dealing with our adding and subtracting, and today we're going to work our way through multiplying and dividing. So you can see what we have on the screen right now are three multiplication problems for fractions. I'm going to make the assumption that you know how to multiply fractions. So if you're sitting there and you're going like, I don't remember how to multiply, then hang tight. We're going to get a review of that. But the way I'm going to talk about this is basically to cover that we know how to multiply fractions. So let's jump into question A. I want you to make sure that you get down the instruction, that our action today is going to be to simplify. And question A, we've got our 3 times 1/2. Now, when we go through that process, I'm going to bet that I would have a bunch of people that have remembered an algorithm that to go through and multiply fractions means you multiply straight across. But similar to adding and subtracting fractions, we may have had that horrible habit, I shouldn't call it a horrible habit, but that habit of going and writing any whole number over 1, so that now we do have 2 fractions, and we know that to multiply fractions, we multiply across. So you would end up jumping in on something like 3/2, and you're good. Okay, I want to backtrack from all of that. Yes, that is our algorithm to go through and multiply fractions. However, I just want us to take a peek again at what A says. It says that you have 3 times 1/2. That means that you have 3 groups of 1/2. So that means that that's really like 1/2 plus 1/2 plus 1/2. So when I take my 3 and I multiply it by 1/2, my fraction times a whole number, since it represents groups of those fractions, I'm hoping you can see that my sizes of bits don't change. All I have are multiple, that's why it's multiply, multiple halves. So the only thing that changes is the top, the number of them. And so hopefully then we can come up with a new, better algorithm based on that understanding. I'm going to get rid of all that gold. We should be good. That if I need to ever multiply a whole number times a fraction, I multiply my tops. And I come right in 3/2. You can very quickly then work your way through B. So take a moment, jot down question B. We now have 2 times 3/4. And so I have a whole number times a fraction, and so I know I can multiply my tops. I have 2 groups of 3/4. So what do I have? I have 6/4. The only thing left for me to do is to go through and reduce. And now I take a look and I notice, hey, I have a common factor of 2 in top and bottom. And therefore I reduce that down to 3/2. Now, one big thing that I'm hoping we can expand on as we move forward is maybe I was good to know that I would have to reduce that fraction. Look back at your original question and look at what I circled in blue. I can see that since I'm going to multiply that top by 2, I actually have a 2 on top and a 2 on the bottom. That 4 on the bottom represents 2 2s. So I can already see that when I do multiply it, I'm going to be able to divide out that 2 from both top and bottom when I reduce. We're going to come back and we're going to talk a little bit about what we just did in question B as we move forward. For right now, I think getting 6/4 and reducing it to 3/2 is great. Okay, we should all be able to move very fast through C, like to the point where I think you already know what that simplified value is. It might just actually take longer to write it down physically, like to physically put it on the page. We should be good pretty quick to say I have a fraction times a whole number. Same thing, multiply my tops. And we know why that's the case. You now have 6 groups of 4/5. So that means you have 24 of those fifths. Okay, I'm hoping that was pretty straightforward for everybody, but maybe we have a better way to tackle some of those problems. Okay, let's jump into our next section. Okay, take a peek at D, E, and F. And what I'd like you to do is just copy down D. Don't get to E and F yet. Just copy down D. And once you have D down, then I'd like you to go ahead and answer it. So I would like you to calculate 1/2 times 1/2. Okay, so you should have D finished. Go ahead and come up with an answer. Pause the video. We'll see if we match up. Pause it now. Okay, we're back. So I am hoping that we have that algorithm that says, hey, if I have a fraction multiplied by a fraction, I can multiply straight across, and we come in on 1/4, and 1/4 is what we should have all got to. I just want us to think a little bit about reasoning here, because sometimes the reasoning we use can help us out. I don't know if we know this. I'm hoping we do, but I don't know if we do. That operation of multiply can be translated into the English word of. That what that algebra or numbered statement actually says is calculate 1/2 of 1/2. And so really what that would say is take your pie, break them up into halves. There's my half. Now take a half of that half. And pretty quickly we should see why we get a value of 1/4. So hopefully reasoning now can kind of make sense for why my denominator changed. I was taking a fraction of another sized piece. So I started with my blue, my halves, but then when I had my halves, I now had to take a fraction of that. So halves became quarters. That's why my denominator changed, but maybe more importantly, and the part that you would love, hopefully, when multiplying and dividing fractions, I don't need common denominators because I'm not collecting pieces of different sizes. I'm breaking up certain size pieces. It's great. No common denominators. Nice. Okay, if we have that, then I want us just to take a look at E. So I'd like you to copy down the question to E. We have 4/9 times 21/12. And I don't want you to answer that question. As I said, I think we should all be able to answer it now. So it's not a matter of can we, but what I want to talk about on E is strategy. Okay, if I put the blinders on and I just wanted to truck through, then I have my algorithm that says I could multiply my top and get 84. I could multiply my bottoms and get 108. But now I just created a fraction, a gold fraction, with some pretty big numbers in it. And now I have to take the time to look over and reduce that to lowest terms. I am going to argue to you why blow things up through multiply to then have to shrink it down later. Why not shrink it down at the beginning? So we could all get that gold fraction. It's just maybe not the most efficient. So what I would like to go through is a process that I'm hoping a lot of you have seen, but it's maybe just not something that we're fluent with. I want to go through the process for us called cross-reducing. It's basically just simplifying your expression, but maybe in a different order. I'm going to do my operations in a different order. When we got down to our gold fraction, we chose to do the multiply because that's what we see in that line. And that's how we got 84 over 108. However, if we look at that whole expression, like don't get stuck looking at it as a fraction times a fraction, but instead we look at that as, well, I have 3 operations that are divide, multiply, divide. Well, that means all I have is multiply and divide. And BEDMAS says I get to do any one I want. So in theory, this is my expression. Notice there is my 84 over 108. But rather than doing the multiplies that I see first, I'm going to focus on my divide. BEDMAS says I get to pick the order. I want to do the division if I can to shrink my numbers down. So I take a look on the top of that line, what I circled in red, and I take a look on the bottom of that line, what I circled in green. And if I can find any numbers that would divide evenly into the top and to the bottom, then I can reduce it right now. Okay, let me get rid of a bunch of those circles, and we'll simply highlight it as the top was red, the bottom was green. So I look at my red numbers, my green numbers, I'm looking for a number that I could divide out. Well, maybe very quickly I look at that and I say, oh, I see within my 4 and my 12. 4 and 12 both have a common factor of 4. 4 goes into those evenly. So I could divide my 4 by 4, so that's why I have 1, and I could divide my 12 by 4 and get 3. There, I'm reducing. Well, maybe I continue on and I say, okay, well, now I take a look and I've got, my 21 and my 9. I notice between the 21 and 9, a 3 goes into both of those evenly. So I'm going to take my 21 divided by 3 is 7, and I take my 9 and I divide it by 3. That's 3. Nice. Now I'm hoping that we take a look at that and we can see that we are finished cross-reducing. However, if we kind of have this as a half idea, we may be tempted to go, hey, look, 3 goes into 3 once and 3 goes into 3 once. And we have got to stop. Yes, I happen to have 2 3s on the bottom, but notice the operation that's between them. It's multiply. It's not divide. That only when I have a number in the red on top and a number in the green on the bottom are those separated by a division operation. So that is as much as I can reduce. Well, all I have to do now is get my expression. So take a look at what I have on top. I have the purple 1 times the blue 7. 1 times 7, 7. On the bottom, I have my blue 3 times my purple 3, 9. And I came right in on a simplified expression. Notice I never blew it up to 84 over 109 and then had to divide top and bottom both by 12 to get down to 7/9. I went straight to 7/9. Now, when you guys take a look at that expression, that's not actually the way I carry that out. But that's the theory behind it. So what I'm going to do is I'm going to go back and I'm going to tackle E again. Okay, let's look at the original expression and we can go through the same process. I might not do it the same way, but the same process. So I notice that I am multiplying both of my fractions. What I want to do is the divides first. So I'm looking my numbers on top, numbers on bottom, and saying, do I have a common factor? So maybe I look and I say, hey, within that 4, I can divide that by 4, and I can divide that 12 by 4. So I just divided top and bottom by 4. Now, last time I did the 21 and the 9, I don't want anybody to think that there is one way you do this. No. So I'm going to do it a little different. This time, I see the 21 on top and that blue 3 on the bottom. And I say, hey, wait a second. 21 divides by 3 and 3 divides by 3. Well, now I look at my numbers on the top. I have the blue 1 and the green 7. The numbers on the bottom are the white 9 and the green 1. I don't have any more common factors. So my final answer, 1 times 7 over 9 times 1. That act that we just went through is often referred to as cross-reducing. But really what it is just reducing your fractions. So I think that is absolutely something that you want to have in your back pocket. Moving forward, I'm going to do that all the time. It really makes us efficient. So what I want you to do is get some practice at cross-reducing. Cross-reducing may be a completely new strategy for you. So we're going to stumble a little bit as we go. Maybe we were just reminded to cross-reducing, and if that's the case, then let's try to get really good at it. So I'd like you to get down question F, and then I want you to try to cross-reduce that and get to a fully simplified expression. Okay, pause it now. Okay, we're back. So there are a number of ways to do this. So really, I want us to be focused that if I take a different path than you, don't get your back up and all of a sudden no, let's see it through till the end. So maybe first thing I notice is my first fraction reduces. That within 20 and 12, both of those have a common factor of 4. So I could divide the top by 4, divide the bottom by 4. Well, now I take a look, and maybe between the 27 on top of the second fraction and the blue 3 on the bottom of the first fraction, I notice that I could divide both of those numbers by 3. Well, I'm still looking for, and I notice, hey, within the blue 5 at top and the white 35 on the bottom, those have a common factor of 5. And so now I could go ahead and multiply since there are no more common factors, and I get 9/7. Hopefully we match up. But it just dawned on me that I might have had an unintended consequence in this process, given what your two gold answers look like. I really hope that I did not put into your mind this idea that, so when we cross-reduce, we always get 9s and 7s. No, that is a complete fluke. So please do not go, I think there's a 9 and a 7 in there somewhere. No, they just happen to work out that way for these two problems. Okay, I think we should be good at having multiple strategies now to deal with multiplying fractions. Let's jump into a next section. Okay, you guys take a look at what you've got on the screen, and I think we're at a moment where we should be able to tackle both of these. So what I want you to do is jot down G and H. I want you to pause the video, work your way through, get a complete solution for both. We'll see if we match up in the end. Okay, go ahead and pause it now. Okay, we're back. So taking a look at G, I would call G a bit of a problem-solving opportunity. We haven't tackled one that looks exactly like it. However, I would argue to you, we should be pretty comfortable to adjust to what we see in G. If you were fine with every problem that came before this, then I think it is the most minor problem-solving acts to say, if you were good with multiplying fractions, then get rid of the mixed number. Change that mixed number into an improper fraction, and now we can go ahead and we can simplify. So I'm going to say you really have the blinders on if you took this green approach and you said, okay, I'm going to multiply those, 36 over 21. And then you spent a line reducing that and saying, hey, 3 goes into the top and bottom. 3 goes into 36 12 times. 3 goes into 21 7 times. I would have loved to have seen that maybe we said, hey, I can cross-reduce up here. I can divide a 3 out of top and bottom and get the blue. And now when I go ahead and I multiply those, I can jump directly to my 12/7. So I think we've really got the blinders off. We're adding to our strategies. If you have the orange to the blue, we maybe put the blinders back on to get to the green. Job 1, be correct. Job 2, let's work to be efficient. So you take a look at the problem solving in that problem, and really it was, so if I have a mixed number, let's just change it to an improper fraction. I think that's a good strategy for you. Okay, I'm going to put a little wavy line down. This is your opportunity. If you feel a little more comfortable with H, or if you need to make adjustments to your solution with H, pause it now, work ahead. Otherwise, you're catching up with me. So we take a look at H, and now what makes this one a little different? Well, you got 3 fractions. 3 fractions should not be more difficult. It should just be more. Like, it's more work, but that doesn't mean difficult. It maybe especially means, man, if I can cross-reduce this thing, I want to. I do not want to multiply straight across on top and go 11 times 15 times 10 all over 25 times 22 times 3. No, I don't want to do that. And then reduce. So I'm going to spend the time to see if I can cross-reduce. And right off the bat, I can see that between the 11 and 22, I can divide out an 11 from both of those. Maybe we then take a look and we say, hey, my 15 and my 25, a 5 goes into both of those. 15 it does 3 times, 25 it does 5 times. But then after we do that, maybe we go, hey, I got 2 3s on top and bottom. I can divide those out. And then maybe we say, hey, look, I have a 5 on the bottom and another 5 in 10, so I could divide that out. And then maybe we look at that and we go, oh my gosh, I have a 2 and divided by a 2. Hey, everything divided out. Well, if everything's all crossed out on the page, everything divided out, my answer must be 0, right? No. You'll notice that as you get better at doing some cross-reducing, you stop writing in the 1s. We just know that they're there. So really what's on the top of that fraction is a 1 times a 1 times a 1. And really what's on the bottom of that fraction is a 1 times a 1 times a 1. You will never write for me on your page 1 over 1. You just know that if you have 1 divided by 1, or the same thing on the top of your fraction as what's on the bottom of the fraction, then the value is 1. So I think if we got an answer to H, and if we matched up on G, I think we're doing great with multiplying fractions. Okay, let's change gears a little bit. Okay, you take a look at the screen and you'll notice we have the same instruction. It's still simplify. But I'd like this to be a separate section in your notes. So when you look back on it, I want it to jump out so this just doesn't like blend in as question I. We want to see it as like section 2. Okay, you have the same instruction, simplify, and now you take a look at question A. We have 6 divided by 3/4. I want you to give that a shot. So I want you to go ahead and pause the video now. Okay, we're back. Now, there are a number of ways to work your way through A. What I'm going to do is I'm going to make an assumption that you have no clue how to divide fractions. You have completely forgot. For anybody who says, I never learned, sure you did. You just maybe haven't practiced it that much. Or you fell into the trap of pushing buttons all the time on a calculator that you've gotten out of shape with it. I'm going to address this in a way that I would not expect you to have a solution. But if this was a test question and you had to write something down, this might have been where you went. You might have taken a look at this and said, okay, I don't remember how to divide fractions. But I do know that I could change that into a 0.75 instead of a 3/4. I know 3/4 is a decimal, that's 0.75. And now this starts to look like a problem we've done in the past. That now you might write 6 divided by 0.75, and now you say, hey, wait a sec, I can move my decimal place 2 spots on the bottom. That means I have to move it 2 spots on the top because I'm multiplying top and bottom by 100. And I at least get to that. Now I have to go through and do some reducing. Like I've got some pretty big numbers there, but at least those numbers end with a 0 and a 5. So maybe I just divide top and bottom both by 5. Well, 600 divided by 5, well, there's my 60 divided by 5, so that's a 12. Then I have my 0 divided by 5 is a 0, so that worked out nice. My 75 divided by 5, well, my 7 divided by 5 is 1, with 2 left over, 25, 15. And then maybe we get to that point where we go, well, I could divide both of those by 5. 12 divided by 5 is 2, with 2 left over. 20 divided by 5 is 4. The bottom would be, hey, wait a second, that whole thing reduces to 8. Okay, you take a look at that green solution, and that is a lot of work. But there is nothing that I put in that green solution that you are not capable of. That was in our rational numbers part 2 lesson. So we get down to an answer of 8. But I maybe want to address this in a better way. So rather than even leave this on, we're going to erase that entire solution. That I would hope that we would at least have an algorithm with us. And if we forgot that algorithm, then pretty quickly we're going to remember. For most of us, we may remember that to divide fractions means I flip and multiply. And maybe you remember it with that wording, flip and multiply, or maybe you remember it in a little more of a formal way of you multiply by the reciprocal. Either of those mean the same thing in this case. So flip my divisor, flip my second fraction, change it to a multiply, and now that that's a multiply, we could come in on our 24, and now we could divide. Or, hey, look, we could have cross-reduced and went straight to an 8. 2 different ways to get there. Now, for us, looking at that red, I'm hoping that that red comes back to us pretty quickly. However, for everybody who's sitting at their desk and is feeling a little cocky about that lesson, and they go, oh, wait, say, yeah, I remembered. Yeah, I know to flip and multiply when I'm dividing fractions. One of the things that gets me the most is how much you have memorized that algorithm. You couldn't tell me why you do that. You just go, I was told that's how you divide fractions, and I have memorized it, and I have done it enough that I am automatic with it. Well, that's not good enough for me. So we need to make sure that we are comfortable with why we do that. To do that, we're going to have to go through a bit of an exercise. And we did this earlier where I had you guys trying to picture something on your desk. Well, we're going to do the same thing today, except we're going to think a little bit about money. So I want you to imagine that you were sitting in class right now. You're sitting at your desk, you're sitting on a table, and what I want you to do is to picture $6 sitting on your table. So right now, stare at your desk, your table, your lap, whatever is in front of you, and you see $6. Can you see it? Okay. Now, what I want you to do is to take that $6 and I want you to break it up into groups of 3/4. Go ahead, do it now. Okay. Some of us are having a bit of a problem with that. And in part, that's because of how we chose to think about $6. So when I asked you to see $6 on your lap, like, did you see a 5 and a 1? Like a 5 and a loonie? Okay, did you see like 3 toonies? 6 loonies? Okay, I really hope we didn't see like 60 dimes. Or really, I hope we didn't see 600 pennies. Okay, take a look and think about what you would want to do at the very beginning. I told you to take $6 and break it up into groups of 3/4. Don't you now wish that when you saw the $6 sitting on your lap, you actually thought about it in quarters? So, don't we want to convert our $6 into quarters? So, how many quarters do you have if you have $6? Well, there's $4 quarters per dollar. So 4 times 6 gives me my 24 quarters. Okay, now on our desk, on our table, on our lap, you see 24 quarters sitting there. Break them up into groups of 3. Put 3 of those quarters in each group. Divide that by 3. And tell me, how many groups do you have? And I'm hoping that you guys can see you would have 8. I want you to take a look at that blue solution, because there's your theory for why we flip and multiply. Why do I flip and multiply? Well, the first thing I need to do is change my units. Remember, the number on the bottom tells you your units. That is the size of your pieces. When you go back and you break up your pie, that determines the size of your pieces. So the first thing we had to do, convert. Okay, now you just changed units. Nice. Well, now what we need to do is deal with the top number. The top number was the number of pieces. And remember, the question I asked you was to put them into groups of 3 quarters. How many quarters? 3. So now we need to break it up into that number. That's where we're doing our division. So I'm hoping that in that blue analogy, you guys can see why we flip and multiply. We change units and then break it up into that many pieces. Okay, let me get rid of that because we all now have a better basis for why we flip and multiply. And let's jump into B as fast as we can go. I think B becomes a really straightforward problem for us now. We see that we're dividing fractions. We know that we can flip and multiply. We now know why we do it. And as soon as we turn it into that multiply, you can see on top and bottom that if you tried to cross-reduce, there will be nothing that divides out. We don't have any common factors on top and bottom, and so we can multiply. You come in on 16/35, and we are good. Nice. Okay, rest of today is about you getting practice and getting really good at your stuff. So, next section. I want you to go ahead and to tackle both C and D. Question C, you've got 2 1/3 divided by 5. I have to be honest with you, that's a really weird looking 5 to me. It looked really small the way I wrote it. There we go. So we've got 2 1/3 divided by 5. And then in question D, that looks really ugly because now you have fractions within fractions. You've got 1 4/5 divided by 4. I want you to go ahead, answer both of those, and we'll see if we match up. Okay, pause the video now. Okay, we're back. So if we were to work our way through C, the fact that I threw a mixed number at you again should not have been a problem. That I would have expected most of us to then be able to say, okay, I'm going to change that into an improper fraction. However, rather than just blindly write out our divide by 5, I think we can now be a little more efficient and say, hey, wait, I know how to divide fractions. I flip and multiply. So I'm going to change it to the multiply. And now I need the reciprocal of 5. So if I flip 5, I have my 1/5. I might be honest with you. This might be the only case where I'm going to tell you it may be beneficial to view the 5 as 5/1. But don't you dare write it. Boo. So you guys come right in on that orange. You've now created a multiply expression. Go ahead and finish it off. 7/15, and we are good. Okay, now we tackle D. Well, the fractions within fractions is an uglier expression. We understand it looks a little confusing. But what that actually means is simply this. 1 4/5 divided by 4. That's what it means. Now, we shouldn't have to rewrite it that way. But what we can do is we can now say, okay, change your mixed number into an improper fraction. There's your 9/5. Now, if that says to divide by 4, dividing fractions means flip and multiply. I'm just going to multiply by 1/4 right away. We can go ahead. There's no common factors to divide out. 9/20 is fully reduced. Hopefully not too bad. Okay, last section. Okay, you take a look at E and F, and my guess is that became kind of ugly pretty quick. No worries, you're prepared for it. So let's use E and F as a real good gauge for us. If you're able to work your way through E and F, I don't really know if there's anything I can throw at you in your practice that's going to get you. So let's get full solutions to both E and F. Let's pause it now. Okay, we're back. So let's take a look at E. I think E should be pretty straightforward. It should have felt that way. It was just more. That we have a mixed number, so 2 times 1, add on 1. 1 1/2 becomes 3/2. I can now multiply that by my 3/5. I see my division fraction, and at the one point, I'm just going to go ahead and flip and multiply right away. And now I take a quick peek along those blue fractions, and I notice there is nothing that will cross-reduce. Don't fall into the trap. Both those 3's are on top. There's no division between them. Both the 2's are on the bottom. There's no division between those. Okay, I am good to now go through and multiply. So 3 times 3 is 9, times 7 is 63. 2 times 5 is 10, times 2 is 20. And I am not going to waste a second trying to see if that reduces, because I can tell right up here, there are no common factors in top and bottom, so I know 63/20 is fully reduced. Okay, let's take a look at F, and if you just picked up on something from E and you want to adjust your solution to F, or you were stumped, didn't get to it, and now you can give it a try, do it. Don't miss out on an opportunity to problem solve. Okay, we're going to jump through F. So I take a peek on F, and maybe I jump and I do this. I don't think it's a bad line to say, and now I flip and multiply. Well, I know if I don't write an operation in there, that means multiply. So I'm going to do that right away. Now, I would take a peek at this, and I would deal with this like an integer operation. We notice that we have some negative fractions. You know what? I'm going to address my sign of my answer right away. Then I can kind of forget about it and deal with my calculations. So I take a peek on top. I'm going to have a negative times a negative. I know that that's a positive. On the bottom, I've got that lone negative. So my fraction will be a positive over a negative. I know my answer is going to be negative. There, signs are taken care of. I don't even have to think about them again. Now I can just look to cross-reduce. Well, pretty quickly, I should be able to see that my 2's are going to divide out evenly. Maybe you divided them out of those 2's, or you divided out of that 4. Doesn't matter. We know it doesn't matter. Now I can multiply all my tops because I have no other common factors. I have a 1 times a 1 times a 5. Notice I'm not even using positives or negatives because I've already addressed the sign. On the bottom, I have a 3 times a 2 times a 2. That gets me down to a 5/12 that I knew was going to be negative, and there we go. So hopefully that wasn't too bad. As I said, hopefully that wasn't too bad, and we were pretty comfortable to get there. Okay, we've now thrown in multiplying, dividing fractions. We should be good moving forward. Your job, make this automatic. Jump in and work your way through your practice. Ask questions if you have them. Okay, best of luck.